Alright guys, so in this video here we're gonna combine several concepts for chapter 2. Mainly deal with linear functions. So we're gonna talk about slope of linear functions, graphs, and models. So this the models will be word problems. One of the by the way, so linear function, the word linear refer to lines. Okay, so um, graphs are linear, meaning are just lines. The not stand but the form that linear function typically goes or known as is the slope-intercept form. Okay, so you probably remember this from the previous class, and that is y equal to mx plus b. Okay, so any equation of linear or a line can be written in this slope-intercept form, just like the name of the form indicate. We have slope and then you have the intercept. So m is stand for slope, and then b is stand for the y-intercept. So slope is what we call the steepness of a line. Steepness of a line. Okay, so to measure stiffness in mathematics, we look at the change vertically over the change horizontally. So with the displacement, the ratio between the displacement of vertically and divide by the change in horizontally. So if we have suppose we have a line like this, then you're looking at, let's say if I want to go from here to there, I want to measure, the steepness of this line here. So you're looking at, how much is the vertical distance being changed over the horizontal distance change. So, we can call this here is, vertical distance. So vertical distance. And then this is horizontal distance. And what you probably know by is not like that, but it's more of your rise over run. Okay, so if we have 2 points, let's say x1 and y1 will be the coordinate for the first point, and then x2 and y2 will be the coordinates of the second point. So if we try and measure, this is your x1 and x2 y1, and then this is x2 and y2, and we try and measure the steepness of this line here. We calculate the rise and the run. So the rise will be equal to the change in y2 minus y1 divided by x2 minus x1. So that's your slope formula there. Okay, so this is how we will find slope from 2 given points. But if it's in this form here, we can just look at the constant in front of x, and that would be our slope, and then this constant here will be our y-intercept. So let's look at an example. How will we find a slope? So let's look at example. So example, find the slope of the line that passes through the given points. All right, so let's look at the first 2 points. Let's do just easy 1, 2, and -5, 7, right? So we look at these 2 points here. If I was to do a quick sketch, a quick plot on the side, 1 and 2 is here, and then -5 and 7. So 1, 2, 3, 4, 5. So that's -5. 7 is up here. 3, 4, 5, 6, 7. So we're looking at up there. So we're looking at the steepness of this line here. Right. Oh, I think I messed that one up. So we just look for the slope of that, right? So slope. Okay. So let's use a formula. Our formula is slope, which shorthand as m, is equal to y2 minus y1 divided by x2 minus x1. So a y2 in this case is, you can choose these points to be any first or second point you want to. If I call this is the first point, that's x1 and y1. This is x2 and y2. All right, so let's go ahead and do that. So 7, so y2 is going to be 7 minus y1 is going to be 2, and then x2 is going to be minus 5, minus x1 is going to be 1, so we're looking at 5 over negative 6, or negative 5, 6, so that is our slope, all right? All right, let's look at another example that deal with fraction. Suppose our 2 points have fractions in it, so let's see what I got here, 1/2, negative 2/3, so 1/2, negative 2/3, and another point to be, let's see, 1/6, comma 1/6. Okay, so we want to find the slope that passes through this, the slope of the line that passes through these 2 points. Okay, so let's use our formula. So m is equal to y2 minus y1, x2 minus x1. So we have 1/6 minus a y1 in this case is negative. A y1 is negative right there. So we got one negative come from the formula, which is this one, and we're going to subtract y1 is negative 2/3, divide by 1/6 for x2 minus 1/2. So on the top we have 1/6 plus 2/3 because negative is positive. And on the bottom we have 1/6 minus 1/2. So I'm gonna go ahead and just leave this like that. I don't know if you remember this, but this is a complex fraction. The way we can simplify this is we can just times the entire fraction by the grand LCD. So I'm gonna say 6 there, because 2 and 3 and 6, the LCD of all those three numbers are 6. So if we do this, we get 1/6 times 6 is going to be 1, plus 2/3 times 6 is going to be 4. And then in the denominator, we have 1 minus 3. So we're looking at 5 over negative 2 as our answer there for the slope. Okay. So that's how you find slope of a line that passes through the 2 points. Now suppose you have some lines that are not slanted, some lines, special lines considered to be vertical or horizontal, right? So we can say, all right, so slope of horizontal line, okay, all right. So if we have a line that looks like this here, let's say it passes through that there. Let's say that's at 5, or 1, 2, 3. So let's do 3. Okay. So if you look at this line, this is a flat line, so there's no steepness in there, right? So you can say, no steepness. So if the line is flat and there's no steepness, we can look at that as a no slope, or we can say 0 slope. Or in other words, m is equal to 0. Well, how do we use a formula to show that slope is 0 in this case? Well, any horizontal line, we can pick any 2 points. So let's say if this is our original point, we can pick another point. Let's say this one here. Let's say if I want to do 2 there, and this can be 2, 3. So we have 2 points there. So 2 points can be 0 there. So 0, 3, and 2, 3. Those are the 2 points to be on this horizontal line. Apply the slope formula. So y2 minus y1 divided by x2 minus x1. So we're looking at 3 minus 3, 2 minus 0. So 0 over 2, which is 0, right? So either way, we get the slope equals 0, okay? Or you can look at this and say, okay, I think I remember that horizontal line. We have the slope of 0, okay? Now let's look at slope of vertical line. Okay, slope of vertical line. Okay, all right. So if we have a vertical line, suppose this vertical line passes through, let's say that is the vertical line. Let's say that is let's do negative 3, right? So if we look at this here and we say, okay, the steepness for this is it is vertical. How do we describe vertical steepness? What will be the mathematical value to capture that, right? So if you look at this case here, the rise is almost infinite, and there's no run there. There's no horizontal change at all, right? So let's look at this more precisely using the formula. Let's use the slope formula, but then that requires to have 2 points. So I'm going to pick this point and maybe another point there. Let's say this is going to be 2. So we're looking at -3 and 2 for that point, and here's -3 and 0. So the 2 points are -3, 0, and -3 and 2. Okay, so let's go ahead and plug that into a formula. We have 2 minus 0 minus 3 minus 3. We're looking at 2 over -3 plus 3. So 2 over 0. Well, if you remember, 2 divided by 0, anything divided by 0 is going to be undefined. Okay, so the slope for vertical line is undefined. Okay, so slope of vertical lines in general is undefined. All right, and slope of horizontal line is always 0, right? Okay, so that's pretty much what I want to discuss regarding the slope and how do we find the slope using the formula. The next couple of videos we're going to look at the graph using slope-intercept form and some more example. Okay.